Hello and welcome everyone to this week's Stellar Developer Meeting. With me today, I have two guests that have been around here before from OpenZeppelin. And what we're going to do today is we're going to take a look at what has been added to the OpenZeppelin toolchain and the libraries that are supporting Stellar for the last quarter. So I'm super excited. I know we're going to talk about smart contracts. We're going to talk about RWAs. We're going to talk about vaults. So yeah, please introduce yourself and let's get started.
Yeah. Hello, everyone. It's really a pleasure to participate again at the Stellar Developer Meeting. My name is Bojan. I'm open source developer at OpenZeppelin, and I'm building the Stellar Contracts Library.
Hi everyone, it's Özgün here. Pleasure to be here. Good to be here, and I'm also an open source developer at OpenZeppelin. We are a team with Bojan, trying to improve the smart contract ecosystem for Stellar Soraban.
Great, thank you. So we've done quite a few hackathons this year, and it's really great to see that some of the developers, they're starting to use OpenZeppelin software and the libraries and the tooling. And I think what you're going to show today is going to be really interesting for a lot of developers. So if you have a presentation you can share.
Yes, I will start. Let me share my screen. Yeah, there it is. Sorry about that. Yeah, so I'm going to present to you today the smart account framework that we created released with the latest release of our library. Just to mention that already a month ago, when with some of you we met at Meridian in Rio, how excited I was, and I guess it was the case for everyone, to use passkeys to have all this like wallet experience abstracted into a smart account. So our ambition is to make this the new normal for Stellar. So yeah, we are building this framework with that in mind. So without further ado, yeah, let's dive in. First, a point about naming and why we chose smart account and not smart wallet. First, the Sorbonne SDK defines custom account and custom account interface, and our design builds on top of it. So that's why we decided to choose smart account as a naming, and yeah, smart account must implement this interface. Then why smart accounts are necessary? Let's just explore a very simple scenario where a smart account that holds some fungible tokens, and the owner of the contract wants to transfer some amount, and that's why they need to call a function on the USDC contract in this case. They will make use of a cryptographic key that is registered at this smart account to authorize the operation. And by looking from this perspective, the perspective of account abstraction, we are establishing a boundary between the account that holds the assets and the keys that control them. Now let's try to define what a smart account is. So this is a smart contract first and foremost that composes authorization intents that are coming from multiple sources. And this high-level definition will guide us through all the components of our framework. With this in mind, let's first see what the authorization sources could be. As in the previous example, an authorization source could be a cryptographic key, or there could be multiple cryptographic keys for the same smart account, or it could be a G account that authorizes on behalf of the smart account, or it could be any combination of these cryptographic keys, G accounts, or other smart accounts and smart contracts. The next part of the definition talked about authorization intents. We'll see what are the core elements of the authorization intent. We can examine this by answering these three questions. We can define who is allowed to act, what they are allowed to do, and how those permissions are enforced. Who is allowed to act? This might be already clear. Those could be some keys from different cryptographic curves, also G accounts, C accounts. What are they allowed to do? Well, here this can be literally any kind of action, either a specific function on a specific contract, or just the transfer function on any ACP41 compatible contract, deployments as well. So yeah, any kind of action. How is this enforced? Also, many different combinations are possible. It could be key 1 and key 2, key 1 or key 2, key 1 and some other conditions that are not derived from a cryptographic scheme. And to give names to those groups, who is for signers, what is the scope, and how is for the policies. How do we compose those elements? So we have signers, scope, and policies, and we embed them in the entity called context rule. Here you see that besides the signer, scope, and the policies, we also have the notion of validity. Context rules function like a routing table for authorizations. For every context, they specify the scope and the conditions that must be met before the authorization is granted. And we'll see how this goes very shortly. So a smart account stores a set of those context rules, and up to 15 rules we can have up to 15 rules per smart account. We added this limit to ensure a reasonable resource consumption and to encourage proactive management. For example, to encourage you to remove the expired or unused rules. And coming back to this authorization mechanism or algorithm, actually it's pretty simple. When the authorization from a smart account is required, first we gather and order all non-expired rules, and then we evaluate them starting from the last added one. Now let's zoom into signers. We have two types of signers, delegated and external. A delegated signer can be any Sorbonne address, G account or C account. And on the right, we group all cryptographic types of schemes or keys in the external variant. And we'll see just in a second why we call it external. But first, how the delegated signer grants an authorization. Code-wise, it's very simple. We use the built-in require out for args function. And however, there is a catch of how we are actually constructing this transaction. I won't dive into this catch. It's like you can find more information about it in the documentation, and there are some code snippets explaining how to get over it. Just mentioning it, and that the cap71 that hopefully gets included in some of the future protocol updates will resolve these issues. So very soon I hope it will be a no issue. The second signer type is the external one for authorizations coming from cryptographic keys. But before we look into that, I'm here providing a list of the curves on Stellar. They're the already available ones that are supported, and BN256 that might get added with protocol 25. And yeah, I guess there could be many more in the future. And you remember the structure of the external signer. Like to go back, it's a tuple of address and bytes. We could have defined its structure like this by enumerating all available curves and the bytes that should be interpreted according to the curve type. But you would agree that this approach is not very scalable, because on every new curve that is added, you have to upgrade your account if it supports it, and this is not practical at all. Another drawback of embedding signature verification into the smart account is that its binary size will grow and the code complexity will increase as well. For example, the classical ED 25119, like it's just one liner, but passkey verification, for example, is pretty much more evolved and requires more code, simply. This pushed us to adopt a way more flexible and scalable approach that is outsourcing and externalizing all type of signature verifications. So we have a verifier contract that stands for this address, and the public key that is the bytes. This verifier contract is a special one. It is deployed only once per curve type or scheme, and should be immutable. It shouldn't keep any state. And in such way, a single verifier contract can validate signatures for any number of keys. And yeah, this was made possible thanks to protocol 23, and that made the cross-contract calls really cheap. Now let's look into policies. So we have here one context rule with the scope, the signers, and the policies. Let's say we have 3 signers, 2 cryptographic keys, and 1 G account. And actually, the policies they modify, they customize the how signers behave. Here in this case, we require any 2 of those 3 signers to sign so that the authorization passes. The policies also can modify some other aspects of the flow. Here in this case, we want those rule to be enforced only for once per month, so that like you can, for example, pay for a subscription. So policies are external contracts as like verifiers. The verifiers are external, so policies are also external contracts. Policies can be stateful or stateless, meaning they can map some state for a specific account and context rule. They can be shared across many different accounts or can be tied just for a specific smart account. And the other aspect is that they have a 4-stage life cycle, which is visible from the interface that those policies must adhere to. Now, if we look into this spending limit policy, it is, let's say it's a stateful policy and it is shared across multiple smart accounts. When this policy is added to a context rule, the install hook is called, and this inits the storage for the calling account and sets the amount and the time period. For example, here we will have 100 USDC and 1 month. This is the init params that are passed. Can enforce is just the read function that is invoked every time the evaluation loop runs. Enforce, on the other hand, it requires authorization from the already installed smart account and can modify the storage and can emit events. Uninstall is called when the rule is removed, so we are cleaning up the policy storage. So install and uninstall are used only once, can enforce on every evaluation loop, and enforce when context rule is matched. So these are the main elements of a smart account. And yeah, to sum it up, we can have up to 15 context rules per smart account, and each context rule contains signers and policies. So let's see some use cases. Yeah, the most trivial one is are the multi-sigs, threshold based or like a weighted multi-sigs. We can have with this setup, we can have time limited app sessions. For example, you install a context rule that is specific for a specific app and it's valid just for 1 day. So you can interact with this app without needing to approve any further transactions. You can add, for example, the keys for AI agent or bot as a context rule and allow it to spend some limited amount of your assets, so it can trade, for example, and you don't risk to get wrecked. Or you can subscribe for some services. So yeah, let's see how the user flow for a subscription will happen. So I have a smart account and I have the sudo rule, like the super admin rule, that has a single signer, my passkey, and there are no policies, and it's valid forever. Then I'm going to some DApp and I want to subscribe to a service. The DApp prompts me to install a context rule that contains the scope of it is the USDC contract, because I'm going to pay in USDC. The signer is the DApp pub key, and the policy is some spending limit policy that limits the spending for up to 20 bucks per month, and I'm subscribing for 1 year. So this is the single transaction I have to do in order to subscribe for this service. And from this moment on, the DApp developer, for example, they can use the OpenZeppelin monitors to subscribe to the install event on this policy. And when this gets triggered, they will, with a relayer, with the OpenZeppelin relayer, they will charge the user smart account every month 20 bucks. So the key takeaways: this framework is a context-centric framework. I will compare it as I'm comparing it very often with the Web2 login experience. For example, when you are logging it with your Google account or your GitHub account, like you authorize the third party with some specific permissions. You grant some scope permission. You don't grant the whole access to your data, but just to very scoped permissions. So we are composing authorization intents through those context rules that contain signers and policies. Another very important aspect is that signature verification is not hard-coded into the smart account. So this is very flexible and very scalable. And this framework enables programmable authorization in that manner. So yeah, if you want to play with it, I'm inviting you to go to our repo and to check our docs. And yeah, I'm pausing it here for questions if there are any.
Great. It was really interesting. We have seen a lot of interest in using passkeys, and I think there's so many ways to do, like, there's so many capabilities in Soroban for authorization, but it's also complicated. It's not straightforward and easy. I think that the wealth of opportunities to create custom policies and authorize your users in different ways, I think it's great, but it's also a little bit complicated. So the framework you present here makes that a lot easier. I think this will be a great way to add a flexible authorization to adapt. So very interesting to see. I think I'll drop the link to the repo or to the documentation. But if anyone has any questions, I think, yeah, Elliot has a question here.
Yeah, did you say that OZ Relay can be used to index track the additions, removals? Yeah, definitely. I mean, there are some events that you can subscribe subscribe for those events on the policies or on your smart account, and yeah, trigger some actions according to whatever you want to do. One naming concern: smart account will likely overlap with Stellar accounts and could confuse the idea that this is a contract. I presented why we went with smart account. Mentioned that this may seem a better fit for this kind of entities. Stellar accounts, you mean the classic Stellar accounts? I suppose this is what you mean. But smart account. We have to give it a thought. But I think it can be distinguished well enough, so not to be confused. It would be great to include a 15-minute demo of building an actual dApp. Great suggestion. I'm taking it. Taking it. Yeah. Okay, then I'm passing it to Oz.
Great.
Hi again, everyone. I'm gonna be presenting the Vault, Token Vault, and also RWA. So let me share the screen. Let's do entire screen. Please tell me if it's successful, because I don't see the streaming tab right now?
Yep, we see your presentation.
Great. Let's try slideshow. So what's it that I'm going to be talking about? It's a uniform interface for integrating with various yield generating strategies, also known as ERC4626 if you are familiar with the Ethereum ecosystem. The problem token vault solving is, let's say you have 1,000 USDC, and what are you going to do with this? You can lend it, you can provide it for liquidity, or you can stake it, right? But these are all the options you can do. Or you can have a manager of your funds for utilizing the best option out there. But for every manager, you will have different problems. There is no interoperability, there is no composability. The UX in general would be bad. So Vault tries to standardize all these, and it still can be managed. So this is what we are trying to do. So you deposit your assets into the Vault. The Vault tries to utilize your assets in the best way and earn some interest, and you will get shares in return. And you can always do transitions between shares and assets. You can convert them interchangeably. So how do we calculate shares and assets? So let's say you deposit your assets and you will get shares. The basic formula for that would be we will multiply the deposit assets by the total shares currently in the vault, and then we divide this result by total assets in the vault, and that whole result will be your shares. This will be very important. So now that I'm going to do some basic math, but it's very basic, so don't be scared. The first action, say Alice deposits 100 USDC into the vault. So for deposit assets, it's 100. Total shares, it's again 100, and total assets is 100. So let's say 10% yield is earned, and now the asset amount per share has increased. So previously, one asset was corresponding to one share, but right now, since the total shares have not changed, it only the interest rate increased the total asset amount in the vault, then this ratio should change, right? Right now, if you provide one share, you will get 1.1 asset in return because 10% of interest rate. And now Bob deposits 300 USDC, and we do this calculation, and Bob will get 272.73 shares in return. So it's not one-to-one mapping as in the case for Alice, because there was 10%, and this is still fine because if you multiply these shares by 1.1, you will get 300. So it is still fair. And let's say another 10% of interest has happened, and now Charlie deposits 200, and the amount for shares would be 165. The problem is, in this previous slide, is we have these decimals, right? This is not an integer, but it's kind of a floating number. This is problematic because how do you handle 3.333 shares, for example? You cannot. So for shares, we round up or down. When do we round down? When do we round up? So let's say you are minting or depositing. We are rounding down. your number of shares, so that you'll get slightly fewer shares than the exact ratio. The reason is Vault cannot overmint shares, and we have to protect the Vault, not the users, so that attacks won't happen. So this is this rounding down goes for minting and depositing, and the opposite one, rounding up, goes for redeem and withdraw operations for Vault. Which creates another problem, which I will demonstrate right now. Let's say, okay, this is the inflation attack. There is a couple of versions of it. Let's say the attacker deposits one's troop. So he minted a share, and right now one share will correspond to one's troop only. Then the keyword here is donates, it's not deposit. So since it's not deposit, it only increases the total asset amount, but not the shares. So it's basically, I'm just giving away this money to the Vault, and I'm not expecting any shares in return. Why would someone do this? You will see the reason. And if you convert the USDC to stroops, you know there are 7 decimal places in Stellar. So we added after 10,000 7 more zeros, and then we added the previous one stroop. You will have this number for total assets. And now Alice deposits 1,000 stroops. So if you divide 1,000 stroops to this total asset amount, you will get something really small, like 0.00001 or something like that. And this will be ultimately 0 because of the rounding down that I explained previously. So basically, Alice deposited some money, which was non-zero. It was 1,000 stroops. But in return, she got 0 shares. And if the attacker redeems their shares, they will get all the money. Basically stealing Alice's stroops. The other scenario would be in here. So let's say again the first 2 scenarios are the same. Attacker deposited 1 stroop, and then they donated 10,000 USDC. And after that, say Alice deposited 10,000 USD. So it's almost the half of the total assets, right? But only 1 stroop short of it. So if you do the calculation, it will be somewhat like 0.99999. But since we don't have any precision for the decimal points, it will again be round down to 0, and attacker would steal all Alice's money, like 10,000 USD, due to this rounding down behavior. So this is the inflation attack. This is not only for our implementation. This attack existed through all the ecosystems, and fortunately, we have a solution for that. The most common one is decimal offset. So instead of this regular or the straightforward calculation, we also add an offset to the power of 10. And it will be something like this. So if you deposit 1 stroop, instead of 1 share, you will get this amount of shares. This is up to your decimal offset. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, you will have 9 for the offset, and you will get this amount of shares. And let's say for the same attack, the attacker then donates 10,000 USDC. They won't get any shares because it's a donation. Then Alice would deposit 10,000 stroops. It would have been this small amount previously if we didn't use decimal offset. But since we are using decimal offset, Alice will get 1 share, and attack won't resolve. So basically, there is no attack due to this decimal offset. Any questions about Vault? And I will just stop presentation, and we'll move on to RWA after questions. By the way, maybe we can also share a link for the Vault implement.
Yeah, just maybe we also want to shout out to someone who helped contributed to
yeah.
the Vault implementation. I don't know if he's on the call, GS Maxi from Sentinel 5. So yeah, he helped with this
he basically
Vault implementation. Yeah.
laid the groundwork, and he also helped us writing the SEP for Vault, which just got merged today, by the way. So we have a new SEP, guys, for the Vault. All right, great. Then I can continue with RWA. So for this one, I'm gonna be presenting over some text instead of slides. Okay. Is it readable, or should I make it bigger?
Maybe just slightly bigger. Yeah, I think this is good.
Great. So RWA, as you know, stands for Real World Assets, and it's more like a suite of contracts compared to a single contract. So it's more complicated and involved. For the base RWA token, you can think of it like a fungible token. It has the same metadata and core functions. But on top of that, we have forced transfer, which the admins can force transfers on behalf of the users. We have freezing, both address level and partial. Partial means we can freeze some part of your wallet balance. For example, maybe you have 2000 in your balance and we only froze 500 of it. And address level is your address is frozen for every like transfer, mint, etc. operation. So basically you are on hold. We do also provide recovery mechanisms in RWA. In case of you lose your private key, then the authorities can recover your wallet by sending your balance to another wallet, and also all the account related information of you as well. For this recovery, of course, you have to convince the authorities by providing the necessary documentation. It's not part of the RWA standard, but this is how it will work on behind the scenes. And you probably already know about pausable operations for the utility for other tokens as well. This is the same for RWA token. We can pause the operations for the contract. So this base token contract is going to be interacting with two modules or stacks. One of them is identity, the other one is compliance. Identity stack will be responsible from verifying your identity, basically, but it's also very involved, and I will get into details later. And the other one is compliance. This is mostly for hooks, post and pre-hooks for the operations. And this exists mostly due to allow organizations or governments or etc. to include or embed their own business logic into transfers and mints and burn operations. So let's go step by step. The RWA token, as I told you, is the main contract, and it communicates with compliance and identity verifier. The compliance is managing 5 hook types, which I will dive further deep into. And the good thing about compliance and identity verifier is they are multi-token support, which means, let's say you have a compliance contract, you can share this with multiple tokens, multiple RWA tokens. So let's say there is another RWA token here. It can also go to the same compliance contract. I will give this example, which I like. Let's say you have Bank A and Bank B in your country, and since they are in the same country, probably the compliance that they need to oblige to will be the same. So they can use the same compliance in this case. Identity verifier, again, this can be shared across multiple tokens. It validates the identity of the investors of this token. I will dive this into later, so let's skip for now. If we go for the high-level basics, for the token, you need to provide the name, symbol, decimals, and initial supply. Very standard basic stuff. Same with the fungible. And on top of the fungible, we will have the freezing mechanisms. We will have a recovery mechanism. We will have forced transfers and pausable operations, as I told you. So right now, I already told about how this compliance and identity stack can be shared. So I'm going to skip this one as well. So let's dive into identity stack. So there can be multiple ways to verify identity. The one we provide, which is the default one, is claim-based. So you can think of it like, I'm from Turkey and I'm a Turkish citizen. And in this RWA setting, maybe the residency is an issue. So I must have a claim from the authorities that I'm a resident of Turkey. So I need a residency claim issued for me by the authorities. And one downside of this approach can be if it is not encrypted, then all the data for everyone, since this is on-chain data, can be seen by everyone. So this is very useful, but also if you care about privacy, it may not be the best solution. So there are other approaches as well, like you can do Merkle tree, you can do ZK email, you can do your own custom approach. We do not provide these, by the way, but they are for sure doable. And we designed the architecture in such a way that this coupling here is not tight, but loose. So you can easily plug this one out and plug your own solution for identity stack. So sorry, here. So basically you can replace the stack here and plug your own. So what do we provide for the default identity? We provide claim topics. These will be known your customer, anti-money laundering, etc. for the topics. We limited the topics by at most 15. We also have trusted issuers. These are all separate contracts, by the way, like this is a separate contract, this is a separate contract, this is a separate contract. And the issuers, the trusted issuers will be able to sign claims on behalf of the users so that the users can use these claims. And we also store the information regarding the identities, like if they are individuals or organization, which country are they based in, etc. So the identity stack is managing all the claims and the topics and also the account related information like individual, organization, country information, etc. The compliance one. So these are the hooks. This is much more straightforward. We have 2 pre-hooks and 3 post-hooks. Transferred, created, and destroyed. So I will start from the pre-hooks. Say your organization needs to run additional business logic for transfers. So before any transfer operation happens, you want to run some custom business logic. You can do that. We have a compliance contract, which will call this hook when a transfer is about to happen. And for this hook to work, you can have your own contracts. We will call them modules. And let's say you have a module for can transfer. So what you would do is you would link the compliance contract to your can transfer module contract. And this compliance contract will call your module on every time there is a transfer is about to happen. And the good thing is you can deploy many contracts per one hook. So for example, you can have 3 contracts that will be called for can transfer, but 5 for can create, which for be minting. This is completely up to you. We decided to go with multiple contracts due to auditability and also separation of concerns. So if you just wrote your logic into this can transfer and then you wrote another logic in this can transfer by pure code, then it would be cumbersome to manage and debug. So that's why all business logics separated into their own contracts, which will be called by a relayer contract or proxy contract, is a better architecture. The same goes for these post hooks. You can have additional logic for all of these. And that summarizes the compliance module. So what about the access control? You have few options. You can go with ownership model or role-based access control. So it's completely up to you. And for each kind of operation, you can assign roles, have very complex role-based access control architecture or very simple one. Again, completely up to you. We now only provide one extension for RWA, which is Document Manager. Enables you to attach some legal documents, etc., to your token. Of course, we do not store the whole document in the blockchain like on-chain. This will be inefficient. We are utilizing the hash. And you can also add your own extensions to RWA. That will be it for the RWA. If you have any questions, feel free to ask. I see one question. Is the RWA design based on any existing stars? Yeah, of course. So we work with Tokeny and ERC Foundation also, in collaboration with Stellar included. So all these companies came together and based on the RWA proposal for the Ethereum ecosystem or general ecosystem, we made it specific to Stellar. So we made some few deviations from the original proposal, and most of our proposals to deviate from it was welcomed, and it will be adopted in the original standard as well. So we also contributed to the maturity of the original proposal as well. So it's not designed from scratch, if that's what you're asking. Okay, great. This was 3 really interesting presentations, and I think it's very aligned with what we see that developers are interested in doing. Yeah, the passkey integration and use that for authorization is something that's very big focus on. And I think this framework you presented is going to help a lot of developers to create a robust framework for authorization using passkeys. The vault is something we've seen an increased interest in. A lot of developers want to build in a way to earn for the tokens that the users are holding in their wallet. So very interesting as well. And RWA, it's also super aligned with what SDF is interested in. So I think this really hits right where the focus is from developer sides today. So super interesting. And I think we did post all of the links, but otherwise go to OpenZeppelin.org, I believe. .com,
Yeah.
and then you can also see all the documentation there. Let's see, was there one more comment? Yeah, I don't think there's any other questions. This is last chance if anyone has a question, but thank you both of you for joining today. It's super interesting to see all the work you're doing, and I think it's super interesting to see some of the libraries you're building, some of the frameworks, and some of the tooling. When we go out to hackathons and when we talk to developers, that we see that they're being used. I think that's the greatest part of it. So thank you everyone for joining, and thank you two guys for being on here again.
And I'm sure we will talk again sometime soon and follow up on the latest development. But thank you for joining, everyone. See you next week.
Thanks for having us.
Bye.
See you.